Hi Math 2, this is an introduction to complex numbers. Before I talk about a complex number, I want to first talk about an imaginary number. So in mathematics, we have numbers that are imaginary. That's kind of fun. So an imaginary number is I. I is equal to the square root of -1. This learning about imaginary numbers is going to allow you to now do problems where you have to take the square root of a negative. So thinking about I being equal to the square root of -1, another important concept, so let me rewrite that so I can use it to show where I'm going with this. If I is equal to -1 and I square both sides, I squared is equal to I squared. And then the square root of -1 squared becomes just -1 because, as we've learned, the square root and the square cancel. And so these two are really important to remember. My imaginary number I is equal to the square root of -1, and I squared then, therefore, is -1. So now let's talk about what a complex number is. A complex number is a number that has both a real part and an imaginary part. So we can write it as a plus bi. And a will be my real part, that's my real number. And b times I will be my imaginary part. So lots of numbers that you know are complex numbers. First of all, let's look at just some regular complex numbers. Like, for example, 2 plus 3i. 2 is the real part, 3i is the complex part. I could do -5 plus 7i. -5 is the real part, -5 is a real number, and 7i is my imaginary part. Together, they are a complex number. But my imaginary part, my real part, either one can also be 0. So let's think about my real part being 0 and my imaginary part being -6i. Well, 0 minus 6i would just be -6i. So -6i is an imaginary number. It's also a complex number with the real part being 0. So all the numbers you're familiar with on the number line, for instance, are also a complex number. Let's say my real part is 8 and my complex part is 0 times I. So 0 times I. In other words, 8 plus 0 would just be 8. The number 8 that you're very familiar with is a real number, but it's also a complex number where the imaginary part was 0. So these are all examples of complex numbers. Please note, and I'll point this out later, the real part always comes first, and the imaginary part that has an I always comes second. In other words, going back up to my first example, we would never write 3i plus 2. We always write the 2 first, that's the real part, and the 3i second. So let's take a look at some examples. Knowing about imaginary numbers now allows me, when I solve square roots, to solve the square root of negative numbers. So for example, I can think in my head of -81 being -1 times 81. The square root of -1 we've just learned is I, and the square root of 81 is 9. We're going to write that as 9i. You would not write the I in front with the 9 behind. We would write the 9 in front as a coefficient and I behind. The square root of 81 is the 9, and the square root of -1 is the I. I is equal to the square root of -1. So let's take a look at a square root that I have to simplify a little bit. So I'm thinking about the square root of -24. That's a -1 times the perfect square of 4 times the leftover part of 6. This equals when I do my square root, the square root of -1 is the I on the outside. The square root of 4 is 2. Remember, the 2 goes in front of the I. It's like a coefficient. And the square root of 6 stays behind. So when we write these numbers, when I simplify my square root, the 2 comes first, the I would be in the middle, and my leftover radical is last. So I first write my coefficient of 2, then I have my imaginary part, my I, which is really equal to the square root of -1. It's not a variable. And then my leftover radical, which is the square root of 6. What happens if I already have a constant term? Well, this is -2 times the square root of -36. So I'm simply going to do my work to find the square root of -36, and whatever I bring to the outside, I'm going to multiply by that -2. So for instance, this is -2 times, and the square root of -36, I'm going to think about that as -1 times 36. So that would be -2 times the square root of -1 is I, times the square root of 36, which is 6. So this is all multiplication. And so to simplify that, I'm going to do -2 times a 6 because they're like terms, they're both integers, and I get -12, and the I goes behind, and the -12 goes in the front. You can try simplifying 1 through 5 on your own and check your answers in the locker and in Google Classroom and bring your questions to Zoom. Let's now discuss operations with complex numbers. Operations with complex numbers would be adding our complex numbers, subtracting our complex numbers, multiplying our complex numbers, and also dividing our complex numbers, which we will not be doing on this worksheet. So first of all, when I add complex numbers, it's basically adding like terms. So I'm going to add my real parts together, and I'm going to add my imaginary parts together. In this problem, my real parts are 5 and 7, and my imaginary parts are the 3i and the -8i. 5 plus 7 is 12, and 3i minus 8i would be -5i. Now make sure you write your answer in what we call standard form. We talked about this just a minute ago. That's the real part first and the imaginary part second. So you would not write this answer, for example, as -5i plus 12. We wouldn't write that. The real part first, the imaginary part second, and I'm going to do that in every single one of these examples. When you have a subtraction problem, you're subtracting two complex numbers, we're going to think of our subtraction as adding the opposite. So I'm going to change my subtraction problem into an addition problem. Be really careful here. I'm basically distributing the negative into my parentheses. So this is 5 plus 3i, and instead of subtracting parentheses 7 minus 8i, I'm going to add the opposite. So the opposite of my 7, my negative, when I distribute it, I get -7. The opposite of +7 is -7. When I distribute my negative -8i becomes +8i, or if I think about adding the opposite, it becomes +8i. So I'm going to change subtraction problems into adding the opposite and drop my parentheses. Now this is a problem just like number 5. I'm going to add my like terms, combine my like terms. So in this case, I have 5 minus 7, and then my imaginary parts is 3i plus 8i. So when I do this, my 5 minus 7 is going to give me a -2, and 3 plus 8 will give me +11i. Again, I'm writing this in standard form. My imaginary part is second, my real part is first. How about multiplication? Well, this is an example of using our distribution property. So I'm going to multiply my negative 5i into my parentheses. So I would get a negative 5i times 4. I can multiply the 5 times 4, it's 20i. In this case, you can think of I, you're treating it like a variable. It's coming along, it's just tacked on the end. But remember, I is not a variable. I is equal to the square root of negative 1. Now be careful here. Negative 5 times a positive 3 is negative 15. But I have an I times an I. I times I would be I squared. I squared is not simplified. If you look back to the top of our worksheet, I squared was equal to negative 1. You have to remember, anytime you're doing multiplication and you get an I squared, you have to write in a negative 1 in place of that I squared. So on the next step, I have negative 20i minus 15, and instead of my I squared is equal to negative 1. That's really a negative 15 times negative 1, or negative 20i plus 15. Now, that's not how I can write my answer because, again, it's not in standard form. My real part has to be first, and my imaginary part has to be second. So a really important part when I'm multiplying complex numbers is to remember to replace every I squared with a negative 1 and then simplify my numbers. Let's take a look at a FOIL or box problem. So this would be a FOIL or box multiplication problem. And let's go ahead and do box with this. It's a 2 by 2 box. And I get 4 negative I, I'll write across the top, and 5 plus 2i down the side. 5 times 4 is 20. 5 times negative I is negative 5i. 2i times 4 is 8i, and 2i times negative I, be careful, the 2 and the negative, I've got negative 2i squared. So this gives me 20. On my diagonal are like terms. 8i minus 5i would be plus 3i, and then this is minus 2i squared. This is where from the problem before, anytime you see I squared, you're going to replace that with a negative 1. So this is really 20 plus 3i minus 2 times negative 1. However, a negative 2 times a negative 1 is positive 2. It's really 20 plus 3i plus 2. And the 20 and the 2 are like terms. I need to finish off my problem by adding them together. So my final answer is 22 plus 3i. The real part first, the imaginary part second. You can try your adding, subtracting, and multiplying skills with numbers 9 through 14 and check your answers in the locker and bring those to Zoom. When you're doing 14 is something called complex conjugates. Notice that the only difference between the two binomials is one has a negative and one has a positive. Something very interesting happens with complex conjugates. It's also how we work with division of complex numbers, which we'll do next year. The numbers 15 to 17 are solving equations where in the process of solving the quadratic equation, this is similar to your assignment from earlier this week, you're going to end up with the square root of a negative number. So let's look at two problems that might help you do these three. So on the back side of the worksheet, you could write down these two additional examples. So for example, to help you with 15 and 16, a similar example to those would be something of this, let's say a squared minus 5 equals negative 15. So this is a situation where I'd want to isolate my a squared term so that I could solve for it. I'm going to add 5 to both sides and end up with a squared equals negative 10. this is where I now take the square root and I find that I have the square root of a negative number. So remember, when you're solving quadratic equations, you want both the positive and the negative root. So we have our plus minus in front. And now negative 10, basically I could think about that as negative 1 times 10. So I'm going to pull out the square root of negative 1, that's my I, and I'm going to leave the 10 inside. This would be written in the correct form. You want to keep the I in front of your square root. So now let's take a look at one that is the quadratic formula. So an example that might help you with number 17, for example, would be, let's do x squared plus 3x plus 4, and we'll set that equal to 0. So now my A is 1, my B is 3, and my C is 4. So when I set up my quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So this gives me x equals negative 3 plus or minus, inside here I have 9 minus 16, which is negative 7, all over 2. Now I can simplify the square root of negative 7. I'm going to think about that as negative 1 times 7, and that simplifies to negative 3 plus or minus. I'm going to bring the square root of negative 1 outside as an I, and that leaves the 7 inside, all over 2. So this is a good answer, but it's not written in standard form. Remember, our standard form is a real part plus an imaginary part. So my plus minus is really like this plus sign here. So I'm simply going to write both parts over a 2. So my two answers would be x equals negative 3 plus my I square root of 7. That's negative 3 over 2, and that's I square root of 7 over 2. I just separated out my two different fractions. They're both over a 2. Or let's do, it's a plus minus, so now let's do the minus. Or x is equal to negative 3 minus I square root of 7, negative 3 over 2, and I square root of 7 over 2. So I just separated it out. So I wrote the real part is in front and the imaginary part is behind. And this would be your answer.